Hey guys, this video is going to review the reasons for the seasons, talk about the angle of insolation throughout the year and how that changes and how that affects the temperature on Earth. We'll talk about the length of day and how that affects the seasons, and then we'll wrap it all up. Alright guys, to help us understand the seasons a little bit better, I'm going to use this piece of software here. It's called Stellarium. It's a planetarium software, which helps us view the sky at any given point in time. And if you take a look down here at the bottom center, we're going to have two things that are really important for us. First of all, here's the date, June 21st, 2013, and it's set for noon. Now, this is the view from Palatine, Earth, Palatine, Illinois. It says it right here. But this is what's important, is I'm pretty much going to stay around noon, but I'm going to advance the day by a week with every click. And I want you to notice something. So here we are, June 21st, and I'm going to start to advance the sun by a week. And notice that it's getting lower in the sky. I know the moon's popping in and out. Don't worry about that. But here we are in August, and here we are in September, and right now this is September 20th. This is right around the fall equinox, right here. But notice that we're still at around 12 o'clock. We've only advanced by a minute or so. But the sun keeps on getting lower and lower in the sky at the same exact time. Let's go ahead and advance a little bit more. I'm going to go into December here. So here we are in November, and here we are in December 20th. And actually, if I click one more day, here's December 21st. And I'm going to put my mouse right there. Again, notice December 21st, and what do we lose that hour? I'm going to go ahead and change that here. I may have hit a button. I'm just going to go ahead and put us here at noon. So here's our noontime sun on December 21st, 2013. And I'm going to go ahead and advance by weeks again. And notice that instead of the sun getting lower in the sky at the same time, it's getting higher in the sky at the same time. And the big question is why is this happening? And now there was our June. It's going to lower. Here's our December. And we can just keep on letting this go. Here's June. Here's December. Here's June. Here's December. And before I know it, I've probably advanced a good 4 years. I have. It's now 11:26:16, and it only took me 30 seconds to advance that far. Keep on watching this. I'm going to do this one more time. Watch the time and the date. Notice that the date is going to change, but the time stays the same, and that the sun's position throughout the year will change at the same exact time. The big question is why? Why do we have seasons? Why is this a big deal? Well, let's take a look at another piece of software to help us out with that. All right, so let's take a look at this another way. So first, let's figure out what we're looking at. On the far left here in this region, we have our Earth orbit viewer. And so if I drag the Earth, click and drag the Earth here, we'll notice that we're changing our date down here and over here. So we just went from June to September, and now we're going to go from September to December, December to March, March back to June. Now I'm going to go ahead and start around June 21st. So there it is right there. And then another view that we're taking a look at here is the upper right-hand view. This is set for a person here in Palatine. And it says the observer's latitude. We're at about 42 degrees north above the equator. Now in this bottom right here, we have the angle, we have the sunbeam spread, they call it. And what that means is this. It's showing if the angle of sunlight that's being cast in that area is direct or if it's spread out. And something we learned from our lab, that if that angle is really spread out like this, you're going to have cooler temperatures. And if that angle is more concentrated like this, you're going to have warmer temperatures. Now also notice that this angle here will change. This is the angle of direct insolation. Direct insolation. Now there's another subtle thing here I want you to take a look at. This little yellow dot. That little yellow dot marks the exact point of most direct insolation for the entire Earth. So right now, given this position, the most direct insolation is striking the Tropic of Cancer. So let's take a look here and take a look and see what we have seasons using this and tying it back into the previous animation that we took a look at. I'm going to change this to go from sunbeam spread to sunbeam angle, and this again is showing that angle of sunlight that we're receiving. So if we move to a lower angle, it'll look like this. If we move to a higher angle, it'll look like this. Higher angle is warmer temperatures, lower angle would be cooler temperatures. So let's kind of take a look at this and see why we have seasons. All right, first thing to notice is this, that we're on June 21st, that's the summer solstice, and if you take a look, here's our equator. And this entire area above the equator is receiving direct sunlight, and there's less area in the southern hemisphere receiving direct sunlight. And if I take this guy and I move him down to the southern hemisphere, I'll move him down to 42 degrees below the equator, because we're about 42 degrees above the equator. Notice how much less of a direct angle the insolation is that he's receiving. Let me go ahead and put it on that sunbeam spread. So notice that the sunbeam is spread out over a much larger area. And again, let me move this guy back up to Chicago, so at about 42 degrees. And at 42 degrees, the sun is much more concentrated in the northern hemisphere, or at much more of a direct angle than in the southern hemisphere. This is one of the reasons why we have such warmer days in the summer than we do in the winter. Now let me go ahead and go to the direct opposite. I'm going to flip this guy all the way over to December, and let's take a look and see the opposite. So here's December, here, good enough, December 21st is right there. So here we are 6 months later. Now notice what happened. That angle of sunlight is now concentrating in the southern hemisphere on the Tropic of Capricorn. The angle of sunlight that person is receiving is indirect, and the sunlight is all spread out. Whereas if we take that same guy and we move him down to 42 degrees south, so the equivalent of we were in the north, everything is going to be the opposite. We have direct sunlight. We have warmer direct sunlight concentrated over a smaller area. So these would produce warmer days in the southern hemisphere. So in our winter, for us, from our perspective, at 42 degrees north, we receive less direct insolation in December, and we receive more direct insolation here in June. So we have warmer days during our summer months, and we have colder days in our winter months because of how much direct or indirect insolation we receive. Now here's something else to mention about this. Let's take this observer and move him further down. Notice again that the further south the guy goes, the more direct the insolation. Now wait a minute, look at this. Here we are on December 21st, and notice that the sun is directly overhead, or the most direct insolation is directly overhead this guy. And if we move him to the equator, and we advance to an equinox, say March 21st, same thing happens. Most direct insolation is directly overhead, with the sun directly overhead the observer. And if we move this guy right here to the Tropic of Cancer, and we advance to the summer solstice on June 21st, we now have the sun directly overhead on the summer solstice. But we don't live at any one of these points. In Palatine, we live way up here at 42 degrees north. There we go, 42, good enough. And notice that all throughout the year, no matter how hard we try, that sun will never be at a 90-degree angle or never be directly above our head at any point throughout the year. The only places on Earth where the sun can be directly overhead would be anywhere in between the Tropic of Cancer, the Tropic of Capricorn, and back up. These are the only places on Earth where you can get the sun directly overhead, because these are the only places on Earth that receive direct insolation all throughout the year. Everywhere else, the sunlight's a little bit spread out. If you're north of the Tropic of Cancer, the sunlight's going to be spread out. And if you're below the Tropic of Capricorn, then the sunlight's going to be spread out. Now let's go ahead and take a look at something else real quick. I'm going to put us on the view from the sun. And notice that this little dot right here is showing where the most direct insolation is for this given day. So in June, the most direct insolation is right on the Tropic of Cancer. And if we move over here again to to September, the most direct insolation is on the equator. If we move over here to December, the most direct insolation is on the Tropic of Capricorn. And if we move to March, the most direct insolation is back here on the equator. And over here to June, we're back on the Tropic of Cancer. And as we move around, notice that that little dot is moving somewhere in between those three major lines, the Tropic of Cancer, the equator, and the Tropic of Capricorn. And this again highlights that the most direct insolation can only be between those points. Highest northern point being the Tropic of Cancer and the lowest point being the Tropic of Capricorn, and somewhere in between the equator and the other two lines. Alright, so here's another look at that angle of sunlight thing throughout the year. I'm going to leave this clock set at noon. Here's June 21st. You're going to notice that the day changes, and this is set for 42 degrees thereabouts for somebody in Palatine. And I'm going to start this animation, and what we're doing is we're advancing 15 days every single second. So if you'll notice, over here on the right-hand side, the days are going kind of nuts here. But notice that it's always staying at noon. And take a look, that the sun is lower in the sky, and then it's cruising up higher in the sky. And here we are at March, and here's April, back to May, and then over to June. So we're back where we started right here, at the sun's highest point at noon. And then as we go all the way back down to December, you're going to notice September, October, November. And so here we are in December, around December 21st, we're at the sun's lowest point in the sky. So what that's showing is that as the year progresses, the sun will reach a lower and lower altitude in the sky. But what about length of day? I'm going to switch this to time instead of day by day. What's going to wind up happening is now we're going to advance. We're going to advance 2 hours every single second instead of advancing a day at a time. So here we have noon on December 21st. And if you'll notice, the sun's going to cruise by really fast. It's now set, and now it's going to rise in just a second here. It's going 2 hours every single second. And now let's see if we can count here. 1, 2, 3, 4, 5, and the sun sets. Let's see if we can get that one more time. We're still in December. We're on December 20th. Let's try this one more time. 1, 2, 3, 4, 5, and the sun sets. Let's go ahead and move this to June. Let's move it to June 21st. This represents the summer solstice. And sun's going to set. Let's go ahead and see if we can count how long the sun is up for. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's try that one more time. Let's wait for it to rise. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, the sun was up on nearly double the amount of time than it was during the winter, and that's just right there in June. So why else do we have seasons? Not only is it the angle of sunlight, but we also have longer days during our summer months and shorter days during our winter months. Why is that important? Think about it this way. Throw something in the microwave for 30 seconds. It may get a little bit warm. Throw something in the microwave for 3 times that amount for 90 seconds. It's going to get pretty hot. Well, that's pretty much what's happening here. The sun is out during the summer for nearly 3 times as long, 2 to 3 times longer than it is during the winter because the days are longer, and it's going to heat up the earth and the atmosphere that much longer. So our days are warmer because of the longer exposure to the sunlight. Whereas in the winter, our days are shorter because we have less exposure to the sunlight. That coupled with the changing angle of insolation, these are things that give us seasons. And what controls all that? That's the tilt of the earth. Alright, in this video, got into how the angle of insolation changes throughout the year and affects our seasons, and also how the length of the day affects our seasons. If you have any questions about this video, please feel free to ask in class or send a message on Schoology.